Hi, welcome back. On today's lecture series, we are going to discuss about power flow solution by Newton-Raphson method. So here the understanding of the method according the empathy stage, the students they are very much complicated in the solving the complex problem and how to solve the Jacobian matrix and how to form the Jacobian matrix, and they are facing the difficulty while connecting the theory into the practical system, and which step has to be comes first and which step comes to the next. There are a lot of struggles in the step-by-step procedure and how the fast convergence can be taken and how we have to implement it is practically in the high voltage system power system, and how we have to maintain the stability, so like that it have a number of empathy question among the community. So from this we have to define certain objectives. So here the main objective we have to achieve the result very much fast, that is in the less iteration method with respect to the number of less iteration as well as the time taken to complete the analyze. So here it is an how to form the Jacobian matrix, and we are including the partial derivative, and we are going for the iterative method through the Newton-Raphson technique. So by using this we can ability to solve 5 plus bus system, like it may be 15 bus system, 30 bus system, 100 bus system. So we can go for n number of systems. So understand the convergence criterion and apply to the real-time problems. So actually in Newton-Raphson and normally it follows an Taylor series expansion. So which is used to solve the nonlinear power flow equations. So the main advantage, we are getting the accurate result. The accuracy is very high. So it is also an iterative method. So until we are getting the exact result, we have to go for first iteration, second iteration, third iteration, etc. If the number of iteration is also increases, but we are getting the exact and actual result, the accuracy is very high. So from this, the mathematical foundation is a Jacobian matrix. So in the Jacobian matrix, we are using the partial derivatives with respect to the partial derivatives of power with respect to the voltage or magnitude or maybe phase angles. So this is the step-by-step procedure of Newton-Raphson method. So here, the step number 1, formulate the power equations. So here it may be given the real power, reactive power, and in terms of the voltage, magnitude as well as angle. So from this we can able to build the bus admittance matrix, and we can initialize them, and we have to initialize the voltages, and we have to assume the bus voltages as 1 per unit for all buses except slack bus. So from this we can able to build the Jacobian matrix. So from this Jacobian matrix, if the buses has 2 cross 2, two number of buses, so we can able to form 2 cross 2 matrix. If we are having 3 bus system, we can able to form 3 cross 3 matrix. So from this Jacobian matrix, we can able to determine the dou p by dou del, dou p by dou v, dou q by dou del, dou q by dou v. That is nothing but the partial derivative of real power as well as reactive power with respect to the angle and with respect to the voltage. So we have to determine all the 4 elements from the Jacobian matrix by using the different 4 formulas, and we have to solve the linear system, and it should be within to find out the mismatch vector, and we have to update the state variable of determining the voltage of all buses except slack bus, and we have to check this voltage with respect to the given convergence criterion. If it is not, again we have to go for the another iterative method till we are attaining the exact the actual result. It should be less than the convergence criterion. So this is the Jacobian matrix. J indicate Jacobian matrix. So this is the partial derivative of power with respect to angle, and this is the partial derivative of power with respect to voltage. So similarly, the partial derivative of reactive power with respect to the angle and the voltage. So we have to determine all 4 elements from the Jacobian matrix. So here just we can consider this is a 3 bus system. So the given data is nothing but the bus number 1 is slack bus, For the slack bus, the voltage value is given as 1.05, angle of 0 degree. And for bus 2, bus 3 is something with PV bus, and bus 3 is PQ bus. So for PV bus, real power and voltage value given, and for PQ bus, real power and reactive power will be given. Okay, now the tolerance is given 0.001 per unit, and the convergent in just 2 iteration. And if you go for Gauss-Seidel, it take around 8 to 12. Okay, so this is an iterative result. At the 0th iteration, we are getting the maximum change in power, and this is the maximum change in reactive power. The status is continue. So we have to continue. We have to go for the another iteration because the tolerance is given. So from the convergence is given. So based on that, we have to go for another iteration. Again, in this 0th iteration, from the first iteration, we are getting the output of change in power and change in real power and reactive power. So again, we have to continue. We have to go for another iteration. So in the iteration number 2, we are getting the maximum change in value. So here we are getting the tolerance value is reached. So it is get converged. So that is why we have to stop the result. It is matched with tolerance level. So these are the real-time applications in power system. So it can be used for the state estimation of by using the PLC and SCADA to monitor the real-time monitoring of the real power, reactive power, voltage, and kVA, power factor. Everything can be monitored in the state estimation PLC and SCADA system. And the renewable integration. So in the modern system, solars, wind, and many renewable energy can be introduced in the bulk amount. So that can be integrated with the non-renewable integration. That is nothing but a smart grid. So we have to expand the power system so that we can use this kind of Newton-Raphson method. And it can be used for the optimal power flow. And we have to be able to do the economic dispatch. And we can able to minimize the loss minimization in transmission networks. So in the industry impact, where NR method is shines. So in the grid reliability, around 99.9%, and for the faster analysis, it will be very 50%. And for bus system, we can use 500 plus bus systems. So that much amount, it would solve the n number of bus system, complex number of bus system, etc. So this is a mind map. So this is my objective. This is our objective. Okay, objective, and we have to form the Jacobian matrix, and we have to compare with the convergence, and we can implement in the large scale integrated power systems. So this is curated challenge. Why North Grid experienced a cascade failure in 2012? How could improve power flow analysis using NR method have predicted stress conditions earlier? So if you know the answer, you can analyze and put in the comment section. And this is another assessment. For a 4-bus system, the Jacobian matrix at iteration k is singular. What would be the possible reason and how would you resolve the issue? So you can put the answer in the comment section. So these are the few references for this topic. Thank you.